In this session, let us explore the different types of storage and the organization for the storage model.
What is a storage model and what are the types of storage? We have SNIA model. SNIA stands for Storage Networking Industry Association. SNIA is a global nonprofit organization which develops standards and education programs to advance storage and information technology. The Storage Networking Industry Association is an association of producers and consumers of computer data storage networking products. It is a registered 501c nonprofit trade association incorporated in December 1997. Its members are dedicated to ensure the storage networks become a complete and trusted solutions organization across the information technology community. The SNIA Technical Council has developed a framework that captures the functional layers and properties of a storage system, regardless of the underlying design, product, or installation. Much like the OSI 7-layer model in conventional networking, the SNIA shared storage model may be used to describe common storage architectures graphically, while exposing what services are provided, where interoperability is required, and the merits and demerits of each architecture. The model describes architectures, but it is not itself an architecture. One cannot buy it, or a system that it describes by specifying it in a bid, or a request for a bid. One cannot build it. The model does not represent any value judgments between the architectures it describes. But instead, the model makes it possible to compare architectures and to communicate about them in a common vocabulary. There are three different types of storage. They are direct attached storage, commonly called as DAS, network attached storage, NAS, storage area network, SAN. DAS, direct attached storage. DAS is the most basic storage subsystem that provides block-level storage, and it's the building block for SAN and NAS. A DAS system is directly attached to a server or a workstation, without a storage network in between. The performance of a SAN or NAS is ultimately dictated by the performance of the underlying DAS, and DAS will always offer the highest performance levels because it's directly connected to the host computer's storage interface. DAS is limited to a particular host and can't be used by any other computer unless it's presented to other computers over a specialized network called a SAN or a data network as a NAS server. A DAS controller allows max 4 servers to access the same logic storage unit. Protocols used for communication between computers/servers and DAS storage systems are FC, or SATA, or SCSI, or PATA, or SASA. The software layers of a DAS system are illustrated in the figure. The directly attached storage disk system is managed by the client operating system. Software applications access data via file I/O system calls into the operating system. The file I/O system calls are handled by the file system, which manages the directory data structure and mapping from files to disk blocks in an abstract logical disk space. The volume manager manages the block resources that are located in one or more physical disks in the disk system and maps the accesses to the logical disk block space to the physical volume/cylinder/sector address. The disk system device driver ties the operating system to the disk controller or host bus adapter hardware that is responsible for the transfer of commands and data between the client computer and the disk system. The file-level I/O initiated by the client application is mapped into block-level I/O transfers that occurred over the interface between the client computer and the disk system. NAS, network attached storage. NAS is a file-level storage technology built on top of SAN or DAS technology. It's basically another name for file server. NAS devices are usually just regular servers with stripped-down operating systems that are dedicated to file serving. Although it may technically be possible to run other software on a NAS unit, it is not designed to be a general-purpose server. For example, NAS units usually do not have a keyboard or display, and are controlled and configured over the network, often using a browser. A fully featured operating system is not needed on a NAS device, so often a stripped-down operating system is used. For example, FreeNAS, an open-source NAS solution designed for commodity PC hardware, is implemented as a stripped-down version of FreeBSD. NAS systems contain one or more hard disks, often arranged into logical, redundant storage containers or RAID arrays. NAS removes the responsibility of file serving from other servers on the network. NAS devices typically use SMB/CIFS for Microsoft compatibility, NFS for Unix compatibility, or Samba for both. Many modern NAS appliances will support SAN technologies like ISCSI, and you can basically build the same hybrid storage solution using a general-purpose operating system like Linux, BSD, or Windows using your own hardware. The difference between NAS and SAN is that NAS does file-level I/O while SAN does block-level I/O over the network. For practical reasons, the distinction between block-level access and file-level access is of little importance and can be easily dismissed as implementation details. Network file systems, after all, reside on disk blocks. A file access command referenced by either the file name or file handle is translated into a sequence of block access commands on the physical disks. The difference between NAS and SAN is in whether the data is transferred across the network to the recipient in blocks directly, SAN, or in a file data stream that was processed from the data blocks, NAS. As the file access model is built on a higher abstraction layer, it requires an extra layer of processing both in the host, file system redirector, computer, and in the function of translation between file accesses and block accesses in the NAS box. The NAS processing may result in extra overhead affecting the processing speed, or additional data transfer overhead across the network. Both can be easily overcome as technology advances with Moore's law. The one overhead that cannot be eliminated is the extra processing latency, which has direct impact on the performance of I/O throughput in many applications. Block-level access can achieve higher performance, as it does not require this extra layer of processing in the operating systems. The benefit that comes with the higher layer abstraction in NAS is ease of use. Many operating systems, such as Unix and Linux, have embedded support for NAS protocols such as NFS. Later versions of Windows OS have also introduced support for the CIFS protocol. Setting up a NAS system, then, involves connecting the NAS storage system to the enterprise LAN, e.g. Ethernet, and configuring the OS on the workstations and servers to access the NAS filer. The many benefits of shared storage can then be easily realized in a familiar LAN environment without introducing a new network infrastructure or new switching devices. File-oriented access also makes it easy to implement a heterogeneous network across multiple computer operating system platforms. In this example, there are a number of computers and servers running a mixture of Windows and Unix OS. The NAS device attaches directly to the LAN and provides shared storage resources. The generic software architecture of NAS storage is illustrated in the figure. Logically, the NAS storage system involves two types of devices, the client computer systems, and the NAS devices. There can be multiple instances of each type in a NAS network. The NAS devices present storage resources onto the LAN network that are shared by the client computer systems attached to the LAN. The client application accesses the virtual storage resource without knowledge of the whereabouts of the resource. In the client system, the application file I/O access requests are handled by the client operating system in the form of systems calls, identical to the systems calls that would be generated in a DOS system. The difference is in how the systems calls are processed by the operating system. The systems calls are intercepted by an I/O redirector layer that determines if the accessed data is part of the remote file system or the local attached file system. If the data is part of the DOS system, the systems calls are handled by the local file system. If the data is part of the remote file system, the file director passes the commands onto the network file system protocol stack that maps the file access system calls into command messages for accessing the remote file servers in the form of NFS or CIFS messages. These remote file access messages are then passed onto the TCP/IP protocol stack, which ensures reliable transport of the message across the network. The NIC driver ties the TCP/IP stack to the Ethernet network interface card. The Ethernet NIC provides the physical interface and media access control function to the LAN network. In the NAS device, the network interface card receives the Ethernet frames carrying the remote file access commands. The NIC driver presents the datagrams to the TCP/IP stack. The TCP/IP stack recovers the original NFS or CIFS messages sent by the client system. The NFS file access handler processes the remote file commands from the NFS/CIFS messages and maps the commands into file access system calls to file system of the NAS device. The NAS file system, the volume manager and disk system device driver operate in a similar way as the DOS file system, translating the file I/O commands into block I/O transfers between the disk controller/HBA and the disk system that is either part of the NAS device or attached to the NAS device externally. It is important to note that the disk system can be one disk drive, a number of disk drives clustered together in a daisy chain or a loop, an external storage system rack, or even the storage resources presented to a SAN network that is connected with the HBA of the NAS device. In all cases, the storage resources attached to the NAS device can be accessed via the HBA or disk controller with block-level I/O. SAN, Storage Area Network. NAS and SAN are two ways of sharing storage over the network. SANs offer a higher level of functionality than DOS because it permits multiple hosts, server computers, to attach to a single storage device at the block level. It does not permit simultaneous access to a single storage volume within the storage device, but it does allow one server to relinquish control of a volume and then another server to take over the volume. This is useful in a clustering environment, where a primary server might fail and a backup server has to take over and connect to the same storage volume. Because a SAN offers block-level storage to the host, it fools the application into believing it's using a DOS storage subsystem, which offers a lot of compatibility advantages. The SAN may use FC, or Ethernet, ISCSI or AOE, to provide connectivity between hosts and storage. The figure gives an example of a typical SAN network. The SAN is often built on a dedicated network fabric that is separated from the LAN network to ensure the latency-sensitive block I/O SAN traffic does not interfere with the traffic on the LAN network. This example shows a dedicated SAN network connecting servers, application or database servers, on one side, and a number of disk systems and tape drive system on the other. The servers and the storage devices are connected together by the SAN as peers. The SAN fabric ensures a highly reliable, low-latency delivery of traffic among the peers. The SAN software architecture required on the computer systems, servers, shown in the figure, is essentially the same as the software architecture of a DOS system. The key difference here is that the disk controller driver is replaced by either the Fiber Channel Protocol stack, or the ISCSI/TCP/IP stack that provides the transport function for block I/O commands to the remote disk system across the SAN network. Using Fiber Channel as an example, the block I/O SCSI commands are mapped into Fiber Channel frames at the FC4 layer, FCP. The FC2 and FC1 layer provides the signaling and physical transport of the frames via the HBA driver and the HBA hardware. As the abstraction of storage resources is provided at the block level, the applications that access data at the block level can work in a SAN environment just as they would in a DOS environment. This property is a key benefit of the SAN model over the NAS, as some high-performance applications, such as database management systems, are designed to access data at the block level to improve their performance. Some database management systems even use proprietary file systems that are optimized for database applications. For such environments, it is difficult to use NAS as the storage solution because NAS provides only abstraction of network resources at the file system level for standard file systems that the database management system may not be compatible with. However, such applications have no difficulty migrating to a SAN model, where the proprietary file systems can live on top of the block-level I/O supported by the SAN network. In the SAN storage model, the operating system views storage resources as SCSI devices. Therefore, the SAN infrastructure can directly replace direct attached storage without significant change to the operating system. Going forward, let us see what is a direct attached storage. We will also explore how a DOS topology integration is done. Direct attached storage, DOS, is a storage system where the computer servers are directly connected to the storage devices. DOS are classified into internal DOS and external DOS based on the location of the storage devices. Directly connected hard disk drives, HDD, solid-state drives, SSD, present internally in the server chassis. Drives connected to the internal bus using PATA, SATA, SCSI, SAS, and PCIe for NVMe drives. Externally connected to just bunch of disks, JBOD, or enclosures consisting of HDDs or SSDs in single disk configuration or redundant arrays of independent disks, RAID, configuration. The JBODs and enclosures are connected directly to the server using SCSI, SATA, SAS, FC, or ISCSI bus protocols. The DOS can be a set of tape drives or a bunch of SMR drives for secondary storage. One of the direct attached storage types is RAID on motherboard, or simply called as ROMB. The RAID on motherboard has a SAS controller populated directly on the motherboard. The SAS controller, also called as RAID on chip or ROC, which is used for RAID on motherboard. An AHCI or a SATA controller populated on the motherboard connecting to SATA drives internally in a same cabinet where motherboard is mounted. The SAS controller is called as an initiator in SAS topology. How do we see a DOS as an internal storage? This has a RAID on motherboard design with disks in an enclosure internally connected to the server. A host bus adapter, HBA, can be also plugged on the motherboard with disks in enclosure internally connected to the server. The storage system is internal to the whole server chassis, constitutes to the DOS as internal storage. DOS as an external storage. Here, a host bus adapter, HBA, plugged onto the motherboard's PCIe's extension with disks in enclosure externally connected to the server. This means that the storage system is outside the server chassis. Now, let us see the hardware used for a direct attached storage system. The direct attached storage has a SAS host bus adapter which is plugged onto a motherboard, or a RAID controller is populated on the server motherboard. Depends of the capacity of storage required. The storage system has hard disks that can be a SAS or a SATA, or it can be a solid-state drive, SSD. The chassis which holds the drives is called as enclosure or a just bunch of disks, or JBOD. A SAS cable is connected between the host bus adapter to the storage system enclosure for data connectivity. A power connector is present to power up the drives in the enclosure device. Let us briefly explore the specifications of a motherboard. The computer motherboard used is a server-specific motherboard. It has multiple CPU sockets. The main component of the server storage motherboard is a high-performance storage controller. Multiple PCIe extension slots for additional adapters to be added to customize the server. Unlike a desktop motherboard, the server motherboard has a moderate display controller. The storage controller can have an additional functionality which is called as RAID on motherboard, ROMB. A high-performance heat dissipation system is needed to disperse away the heat generated by high-performance CPUs and the storage controllers. Multiple high-speed Ethernet ports needed for the data connectivity over LAN or Internet to extend the storage system. There are multiple processors present on a server motherboard. High-performance multi-core and hyper-threading CPUs optimized for heavy I/O operations and device management with a high-end CPU organization architecture. These CPUs need a discrete video card externally connected if the motherboard intends to have a graphical user interface. The CPU has a large cache memory and an optimized cache management unit. It also embeds a high-end error checking and correction, ECC, for RAM. Multiple cores in a CPU are especially seen. For example, we have Intel Xeon E5, 2600 series and AMD's Opteron series. These CPUs have a capability of load-intensive processing along with long life. Hyperthreading for virtual cores is commonly seen in the Intel processors. A multi-core processor is a CPU with two or more separate processors, or to be more technically precise, two or more processing cores, integrated onto a single chip. Due to the increasing popularity of server virtualization, the total number of cores available on servers are useful in virtualization of hosts. Even though CPU cores are rarely assigned to virtual machines in a 1-to-1 ratio, the number of available cores in a server is a merit on the number of virtual machines that the server can host. In the picture you see a SAS host bus adapter, also called as HBA. An HBA is sometimes called an HBA card. HBAs are typically defined by interconnect technology, speed, port numbers, and type of system interface. The HBA card often plugs into the PCI Express, PCIe, slot of a server. Other HBA form factors include mezzanine cards for blade servers. SAS HBA is a computer hardware that physically connects host system to SAS or SATA devices. SAS HBA provides I/O processing between host and SAS/SATA devices. The HBA uses a PCIe bus protocol towards host server and SAS/SATA protocol towards storage devices. Power is supplied through PCIe bus. The SAS Generation 1 has a data rate of 3 Gbps. SAS Generation 2 has a data rate of 6 Gbps. The current is SAS Generation 3, which has a data rate of 12 Gbps. The future is SAS Generation 4 with 24 Gbps, which is in progress. A SAS cable is a physical interface between the host bus adapter and a storage device. SAS cables adhere to serial attached SCSI protocol and also SATA protocol. One end connects to the HBA-X4 port, initiator, and the other end connects to 4 drives, targets, or a JBOD. Cables are available in different configurations for external and internal DOS. All SAS cables adhere to SFF specifications. The end devices can be SAS, SATA, tape drives or a JBOD. Some cable types have SAS connectivity with power supply connectors. The SAS cables have a sideband wires that connect to the backplane of the enclosure or a JBOD, which carries LED-related information from the HBA to the backplane and vice versa. It can also read the info from the backplane to see the type of backplane connected. The physical connection is over SFF8485 or a vendor-specific or an I2C protocol. The number of physical wires in a sideband wire, however, remain the same for I2C and SFF8485 specification-based serial general purpose input-output or SGPIO. A JBOD is abbreviated as just a bunch of disks or just a bunch of drives. JBOD is an alternative to using a RAID configuration. It contains unconfigured collection of disks. The disks within the array are either spanned or treated as independent disks. The spanning configurations use a technique called concatenation to combine the capacity of all of the disks into a single, large logical disk. Some RAID levels do concatenate disks. The numbered RAID levels generally use striping or parity. This is not done in JBOD. The disks with the JBOD can be used for configuring them into a RAID configuration. The whole JBOD constitutes a storage system. The JBOD having a direct attached backplane constitutes a direct attached enclosure. The disks go into the bay or slots, which consists of a sliding tray and a place for a disk to be bolted on it. The JBOD has status LEDs for activity, locate and error indications for individual disks. A target device is a physical entity used for storage. The target devices are individual devices which include SAS hard disk drive, SATA hard disk drive, SSD, which is a solid-state drive. This has be either a SAS or SATA type. Tape drives. Optical drives like CD-ROM and DVD drives. The storage box or the JBOD consists of all SAS, SATA, SSD drives or can be a mixture of these. Now let us see the software components used in direct attached storage server system. Here are the host software details. The server has a customized and optimized operating system. It can be an enterprise Linux, Microsoft Windows Server OS or a FreeBSD operating system. Host bus adapter device driver module for the respective operating systems like Linux, Windows, FreeBSD, Solaris VMware etc., is a kernel module which interacts with controller present on the host bus adapter. SAS adapter management utilities, for managing controller, connected devices runs on the operating system. I/O utilities or tools, for basic testing such as FIO, Medusa etc. Embedded software which runs on the HBA controller is called as a firmware. Firmware is flashed on host bus adapter flash memory or it can be loaded from the host during system boot. Now let us see what are pre-boot components. Pre-boot components are the software components that are present on the host bus adapter. The one we have is the legacy BIOS. All the latest motherboards use UEFI system which is much versatile and has more features and functionalities than the BIOS. Before installing an operating system, if the storage system needs to be pre-configured, the pre-boot components are useful to configure the disks for any RAID levels or to perform any pre-OS load operations like format disk, complete erase of disks or in importing and removal of any foreign RAID configurations that are present in the disks if any. Now let us see the storage management software applications. The storage management applications are used to manage the whole storage system hardware and the software components of the storage system. For example, OpenStack, Redfish are some of the storage management applications. Now let us figure out the components that are needed to build a direct attached storage server. We can call these components constitute as a storage system kit. Let us see the specifications of the needed components. First, we need to have a motherboard capable of handling server capabilities and a CPU or multiple CPUs for that motherboard. A SAS host bus adapter or HBA for the storage system. A distributed power supply for powering the motherboard, CPU, and the storage system. Physical disks needed are of type SAS, SATA, SSD depending on the configuration that a user needs and a housing that constitutes a JBOD. SFF specification SAS connecting cables for connecting the storage system to the server and network cable for connecting the server to the intra or internet. The server motherboard needs to be mounted on MDF board with power supply. The miscellaneous items such as a LED monitor as a display unit and a keyboard with a mouse for user to operate on the server system. A operating system needs to be installed on a drive that can be either connected to the motherboard's AHCI controller or on a drive that is connected to the SAS storage controller. The selection of the operating systems can be either an enterprise Linux, Microsoft Windows Server, FreeBSD OS, or a platform virtualization host operating system like VMware, Citrix Linux having hypervisors that can make the storage server as a host to run multiple virtual machines on it. A storage management application for managing the storage server system can be post-installed for the operating system. Assignments. Implement a storage server for a small-scale business and explain its block-level functionality. Explain with diagrams how servers for education societies are set up. Explain in details how web servers are built and explain its hardware and software components. What is information sharing? How can you use a direct attached storage, DAS, with network attached storage, NAS, to implement this? Explain the merits and demerits of DAS, NAS, and SAN. How can you convert a desktop PC into storage server? Briefly explain which components you are going to add or remove for this purpose. What is virtualization? How this is achieved?
This is the end of the session. For any queries or more information, please log in to www.sbkmake.com. Thank you.